Something strange is happening on the sun right now, and very few people are talking about it. NASA's satellites captured images yesterday morning that honestly stopped me in my tracks. There's a massive dark circle forming on our star, and it's not a sunspot, it's not an eclipse, and it's definitely not something you see every day. This thing has been growing exponentially, nearly doubling in size in just 24 hours, and right now as I'm recording this, it's pointing directly at Earth like a cosmic cannon. The solar wind streaming out of this hole is racing toward us at 700 kilometers per second, more than twice the normal speed, and NOAA is telling us it's going to hit our planet's magnetic field tonight. So what exactly is this thing, and what's going to happen when all that high-speed solar wind slams into Earth in just a few hours? Let me show you exactly what we're dealing with here. This is the sun as of yesterday morning, January 7th, captured by NOAA's GOES-19 satellite. That massive dark circle you're seeing is what scientists call a coronal hole, and this particular one has formed into an almost perfect circle, which is actually pretty rare. Coronal holes appear dark in these extreme ultraviolet images because they're cooler regions in the sun's outer atmosphere, around 2 million degrees Kelvin, but cooler than the surrounding plasma. More importantly, these are regions where the sun's magnetic field lines have opened up into space instead of looping back to the surface. Think of it like this. Normally, the sun's magnetic field creates loops that hold plasma close to the surface, kind of like magnetic cages. But in a coronal hole, those field lines are wide open, creating what scientists call a magnetic superhighway directly into space. Solar wind that would normally be trapped just pours out freely, racing away from the sun at incredible speeds. Now here's what makes this urgent. This coronal hole is positioned almost perfectly at the solar equator, and that means the high-speed solar wind it produces gets funneled directly toward our planet as the sun rotates. It's like standing in front of a fire hose that just got turned on. According to NOAA's Space Weather Prediction Center, this high-speed solar wind stream is expected to trigger a G1 minor geomagnetic storm starting late tonight, possibly extending into tomorrow morning. Some of you might remember this same coronal hole from about 27 days ago. That's one full solar rotation, and yes, this same feature was responsible for G1 storm activity back then too. But here's where it gets interesting. As this solar wind races toward Earth at 700 kilometers per second, it creates what's called a co-rotating interaction region, where fast-moving particles slam into slower ones, creating a compression wave. And we've actually got a perfect storm scenario developing. Along with this coronal hole high-speed stream, NOAA forecasters are tracking two coronal mass ejections that are predicted to deliver glancing blows to Earth's magnetic field. When you combine even weak CME effects with a strong high-speed stream from a coronal hole, things can add up. Now here's where I want to ask you something. NOAA is being pretty conservative with their forecast, calling for G1 minor storm conditions with moderate certainty. But we've seen before that when multiple solar wind structures interact near Earth, the effects can sometimes exceed predictions. Do you think NOAA is being appropriately cautious here, or have you noticed over the years that these conservative forecasts sometimes underestimate what actually happens? Drop a comment below because I'm really curious. Have you noticed auroras when forecasts said they'd be minimal? Let's talk about what this means practically for tonight. If you're anywhere in the northern tier states, roughly from Washington and Montana through the Dakotas, Minnesota, Wisconsin, Michigan, over to Maine and possibly New York, you've got a decent shot at seeing auroras tonight. You'll definitely need clear skies, dark viewing locations away from city lights, and some patience. The NOAA Aurora view line shows potential visibility across at least 12 to 15 states. For those further south, don't get your hopes up too much. G1 storms typically keep auroras at higher latitudes, though there's always the possibility of surprise overperformance. That's actually happened several times this solar cycle, hasn't it? And that brings up something important. You can't really predict how strong a geomagnetic storm will be until the solar wind actually reaches the Dieskova satellite sitting at the L1 point about 1 million miles from Earth. What really matters is whether the magnetic field embedded in that solar wind is pointing southward. If it's pointing south, it can couple efficiently with Earth's magnetic field through magnetic reconnection. If it's pointing north, the effects are much weaker. So when forecasters say there's moderate certainty, what they're really saying is, we know the high-speed wind is coming, but we won't know the magnetic field orientation until it's at our doorstep. That's one reason why NOAA's new SWFO L1 satellite, which arrives at L1 in just 12 days on January 20th, is such a game changer. Now here's something I want to emphasize. We are living through solar cycle 25, and we passed the solar maximum back in October. Some people think that means the exciting stuff is over, but that's absolutely not true. Historically, some of the most powerful space weather events happen during the declining phase, sometimes years after the peak. The famous Halloween storms of 2003, including that monster X45 flare, happened 2 years after solar cycle 23's maximum. So don't let anyone tell you that 2026 is going to be boring. Coronal holes actually become more common and more persistent as we move towards solar minimum. They can last for months, returning every 27 days as the sun rotates. Let me give you the timeline for tonight. The forecasters are saying effects should begin impacting Earth's magnetic field late tonight, January 8th, into early morning, January 9th. For North America, that's late Wednesday evening through Thursday morning for the East Coast, earlier for the West Coast. The KP index forecast shows potential for values reaching 4 or possibly 5, which corresponds to that G1 minor storm threshold. Even if the storm stays at G1 levels, that can still produce beautiful auroras at high latitudes, cause weak fluctuations in power grids at extreme northern locations, and create minor impacts on satellites and high-frequency radio. So here's what I want you to do. First, if you're in one of those northern states, check your local weather forecast for clouds. Second, check NOAA's Aurora dashboard tonight before you head out. That 30-minute forecast updates continuously. Third, share this information with other people who might want to see auroras. Now let me ask you this. We're looking at this beautiful, almost perfectly circular coronal hole sending high-speed wind our way. Conservative forecasts call for minor storming. Do you think tonight's going to surprise us with stronger activity than forecasted? Or will it be exactly as predicted? I'd especially love to hear from those of you who've been following space weather for decades. Drop your predictions in the comments, and if you catch auroras tonight, come back tomorrow and let me know. If you found this breakdown helpful, hit that like button, subscribe if you want to stay updated on space weather, because we're definitely not done with interesting events in 2. Check the description for links to NOAA's Space Weather Prediction Center and those stunning images from NASA showing this massive circular coronal hole. Stay curious, keep looking up, and maybe tonight you'll see those dancing lights courtesy of a hole in the sun.